Hello everyone, welcome back to the course Digital Signal Processing. In the last class, we studied about some of the properties of digital signal processing, that is nothing but linearity property and the time shifting property. And we saw several problems which are associated with the linearity property. In the today's class, let us try to solve some of the problems which are associated with the time shifting property. Okay, so that is here is the one of the problem what they have given you. Okay, so what is that? Find the 4-point DFT of the given sequence x of n. They have given you the sequence 1, minus 1, 1, minus 1, and by using the time shifting property, find the DFT of the given sequence, that is y of n is equal to x of n minus 2 mod 4. So first what you are supposed to do is you need to find the 4-point DFT of the given sequence. Okay, so let us try to note down what are the things they have given you in order to solve the given problem. What are the things they have given in order to solve the given problem? So they have given you x of n. So please make a note of this x of n, 1, minus 1, 1, and then minus 1. This is the they have given, and they say it is a 4-point DFT, therefore n is equal to 4. Now what you are supposed to do is you need to find the 4 twiddle factor, that is for omega 4 to the power of 0, omega 4 to the power of 1, omega 4 to the power of 2, and omega 4 to the power of 3. You need to find it out. Okay, and one simple method we can easily find the twiddle factors is as we did for the 8-point DFTs. So you draw an circular radius. Okay, so a real axis over here and the imaginary axis over here. So at this you'll be getting a omega 4 power 0, and this you'll be getting omega 4 power 1, and here you'll be getting omega 4 power 2, and here you'll be getting omega 4 power 3. Okay, so since it is a real axis, so this will be 1, the radius is 1, and this is will be minus j, and this will be minus 1, and this will be plus j. Therefore, if you write the omega 4 power values, okay, omega 4 power values, that is the k is ranging the value 0, 1, 2, 3. So you'll be having the values, so that is nothing but 1 minus j minus 1, and you'll be having a plus j. Okay, so these are the first things what you are supposed to have. Now what you are supposed to do is you need to find the n-point DFT, that is a 4-point DFT of the given signal. So we know that the expression, that is nothing but x of k is equal to summation n is equal to 0 to 3, because n is 4 here, x of n into omega 4 to the power of k into n, where k is holding the value 0 to 3, where k is holding the value 0 to 3. Okay, so now let us try to substitute the value of n. Let us try to substitute the value of n and try to replace it. So what is this? It is nothing but x of 0 omega 4 to the power of 0 into k plus x of 1 omega 4 to the power of 1 into k plus x of 2 omega 4 to the power of 2 into k plus x of 3 omega 4 to the power of 3 into k. Okay, so now let us try to substitute the value. X of 0, what is that? 1. So 1 into omega 4 power 0, what is that? It is 1. So now what you'll be getting is 1 you'll be getting. Now the next thing what you'll be getting, x of 1, what is x of n is minus j is there. Okay, x of 1 is minus 1 is there. So x of 1 is minus 1 is there. So you'll be getting minus omega 4 to the power of k you'll be getting. Okay, next plus x of 2 is plus 1 is there. So therefore you'll be getting omega 4 to the power of 2k you'll be getting. The x of 3 is minus 1 is there. So therefore you'll be getting minus omega 4 to the power of 3k you'll be getting. So this is what you'll be getting a x of k. Okay, so this is what you'll be getting a x of k. Now let us, what you're supposed to do is, so substitute the values of k values, so you'll be getting the answer. Substitute the values of k. So first I will be substituting x of 0. So when you substitute, what you'll be getting, so 1 minus omega 4 power 0 plus omega 4 power 0, this will be 0 anyway, minus omega 4 power 0 anyway, it will be minus. So what you'll be getting, okay, so what is this? So 1 minus omega 4 power 0 is 1, and plus omega 4 power 0 is 1, and minus omega 4 power 0 is minus 1. So therefore you'll be getting the answer is equal to 0. That is nothing but x of 0 is 0. You got it. Okay. So now what? Substitute k is equal to 1. So when you substitute k is equal to 1, what you'll be getting? Substitute k is equal to 1. That is nothing but x of 1 is nothing but 1 minus omega 4 power 1 plus omega 4 power 2 minus omega 4 power 3 you'll be getting. So if you substitute all these values, so what you'll be getting is, so for this also, so you'll be getting the answer is equal to 0. Okay. Next, substitute k is equal to 2. When you substitute k is equal to 2, what happens? 1 minus omega 4 power 2 plus omega 4 power 2 into 2. What you'll be getting? 4 you'll be getting minus omega 4 power 3 into 2 you'll be getting 6. Okay. And we know that if you remember periodicity of the twiddle factors, so how we can write the periodicity of the twiddle factor? We know that omega n to the power of a plus n, it is nothing but omega n to the power of a. So we can split this with a periodicity, we can split this with a periodicity. Okay, so what we can write? That is 1 minus omega 4 to the power of 2, this we cannot write anything. And what we can write is omega 4 to the power of 0 plus 4 minus omega 4 to the power of 2 plus 4 we can write. Okay, so if you write this, what happens? 1 minus omega 4 to the power of 2 plus omega 4 to the power of 0 plus minus omega 4 to the power of 2 we can write. Okay, so now if you substitute these values, so what you'll be getting is, so the answer what you'll be getting is x of 2 you'll be getting which is equal to 4. X of 2 which you'll be getting which is equal to 4. Similarly, you will need to find x of 3. So when you substitute x of 3, what you'll be getting is which is equal to 1 minus omega 4 to the power of 3 plus omega 4 to the power of 6 minus omega 4 to the power of 9 you will be getting. So if you simplify this, what you'll be getting? 1 minus omega 4 to the power of 3 plus omega 4 to the power of 2 plus omega 4 to the power of 4 plus 4 plus 1. So you'll be getting 1. Okay. So if you substitute this, sorry, here this will be minus sign is there. So if you substitute this, what will be answer is, so you'll be getting the answer is equal to 0. You'll be getting a answer which is equal to 0. So therefore, what is the values you'll be getting? So 0, 0, 4, 0 you'll be getting. You'll be getting the answer x of k is equal to 0, 0, 4, 0. This is the answer you got. Okay. So but this is the first half is over. Now what is the second half? They have asked you need to find the DFT of the given sequence. You need to find the DFT of the given signal, that is y of n, which is equal to x of n minus 2 mod 4. You need to find the DFT of this. Okay. So when you find the DFT of this, and they said you need to use the shifting property, you need to use the time shifting property, time shift property you need to use. Okay. So let us try to apply DFT on both the sides. So what happens? So DFT of y of n, DFT of y of n, it is nothing but the DFT of x of n minus 2 mod 4. This is the property what you have. And we know that the DFT of, so in general, we know that what is the time shift property? We know that the DFT of x of n minus m mod n, that is a time shifted property. We know that it is nothing but omega n to the power of k into m into x of k, x of k. So if I correlate this with this expression, so what you will be getting is, that is nothing but the DFT of y of n, the DFT of y of n, it is nothing but omega n to the power of 2 into k into x of k you will be getting. Anyway, we already know that what is x of k, and by substituting this expression we can easily find it out. And since it is a 4-point DFT, okay, so therefore I can write this DFT of y of n is, I can write it as y of k, it is nothing but omega 4 to the power of 2k into x of k I will be writing. So now what you are supposed to do is, you need to substitute the value of k values, that is 0, 1, 2, 3. So you go on substituting the value. So y of 0, so y of 0 what will be getting? Omega 4 to the power of 0 into x of 0. Okay, so what will be getting omega 4 to the power of value is 1, and x of 0 is also it is 0. So therefore the answer will be getting it as 0. Next, similarly substitute the next values. So when you substitute the next value, so y of 1, so y of 1, that omega 4 to the power of 2 into x of 1. Okay, so what is omega 4 to the power of 2 value? So it is nothing but it is minus 1. Minus 1, what is x of 1? X of 1 is 0. X of 1 is 0. So therefore the answer you got it as 0. Similarly, y of 2. Y of 2, what is this? Omega 4 to the power of 2 into 2, that is 4 you will be getting, and x of 2 you will be having. What is this? It is omega 4 to the power of 0. I can write by using periodicity into x of 2. So what is this? Omega 4 to the power of 0, 1, and x of 2 answer is 4. So that therefore you'll be getting the answer is equal to 4. Similarly, the next one. So what is the next one? So substitute k is equal to 3. So you'll be getting y of 3 is nothing but omega 4 to the power of. So what is this? It is 2 into k. So 3, if you substitute, you'll be getting 6k multiplied by x of 3 you'll be getting. So which is nothing but by using periodicity 6k I can write it as, that is sorry, only 6 you'll be getting. So I can write it as omega 4 to the power of 2 into x of 3 you'll be getting. Okay, what is omega 4 to the power of 2? Which is nothing but it is minus 1. So it is minus 1, and if you substitute this x of 0, that is x of 3, the answer is 0. So therefore you'll be getting a 0. So therefore y of k, and I write it as, so it will be 0, 0, 4 and 0. So the starting indexing value is equal to 0. Okay, so this is the answer for the given problem. Thank you.